Hello everyone. Today we will be solving a very popular Leetcode problem, two-sum. So this is the problem description. Given an array of integers, nums, and an integer target, we need to return the indices of the two numbers such that they add up to target. So since we need to keep the original indexes, we can actually, sort this and use two pointers. So the best approach here would be to use a hash map. So basically we need to find the two elements here that add up to the target. There's only one match, and you need to return their indices. So first I'm going to give you the most trashy solution that you can think of, which is a brute force approach, just to demonstrate what we're actually going to be doing here. But again, this is a very trashy approach, so don't do this. So we're just going to make, like a nested loop like this. And if, let's say, nums I plus nums j is equal to target, then we're going to obviously return we're going to return I and j. So this should work, right? And it does. And I mean, it's a good approach for a beginner, but it's not the optimal approach here. As you can see, runtime is absolute trash. 21%. I mean, memory is fine because we didn't really use any memory. This is O1 memory, but the runtime is ON squared, so that's not good. That is going to be quadratic runtime. As you can see with the nested loop, we have two nested loops, so that's not good. Basically, in this approach, we're going to be going through every pair of indices that is possible here, and we are checking if they equal target. As you may think, that is extremely inefficient and it will take a lot of time. So you see the submission here, it's going to take over 1,000 ms, as you can see here. So 16%, that's trash. We don't want that. So what we can actually do is we can make a hash map. Okay, so let's just say an empty hash map here. All right, and we're going to do here is we're going to, so let me just demonstrate what a hash map is. So how do you even comment this? So what is a comment? How do you comment? I have no idea how to do a comment on Python. Well, that's sad. Anyways, a hash map is a data structure where you have a key and you have a value. So each key and a value, okay, each key points to a value. So for example, here, let's say we have this example, put this in, and we're gonna just say, does this work as comment? No, it still does not work as comment. I don't even know how to do a comment. That's incredibly disgusting. But this temporary. Okay, so our hash would be like 2, and that's index 0. 7, which is the key, points to index 1. 11 points to, index 2, since it's 0 based in Python. And this will be index 3, something like that. This is a hash map. Hash map is basically a list, but better. So when you're having trouble with something, sometimes a hash map can help simplify things. They can store data very well. So what we need to do here is for index value in enumerate nums, basically enumerate here just takes the index and the value here, returns a tuple, or yeah, I think it returns a tuple. So enumerate here just grabs the index and the value for you. Pretty convenient. You don't really have to use it, but it is convenient. If value not in the hash map, we're going to say hash map value is equal to its index. So basically, we're going to take each element and keep track of its latest index, right? Okay. And actually, we don't need to do this. So let me see. So our target, if we already know one number, it's just going to be target minus that number, right? So if we have element 2 and our target is 9, what number do we need to fulfill that? And that's 7, right? If we have 11 and our target is 9, it's 9 minus 11, that's -2, obviously. We're not given negatives here, I don't think. Or we are actually, so maybe. If our number is 3, and we're trying to, get to the target 6, we need another 3, and obviously that's not possible. Okay, so you get how it is. So let's just say the remaining number is equal to target minus the current value, right? So if the remaining number is in the hash map, then we just return this index and the hash map of the remaining number, right? Because that will return the hash map of the remaining number will return its index. So that's all good. Otherwise, hash map value is equal to its index. Okay, so this should work. Basically, we're using hashing to do this now, and it should be a little bit better than the 16%. So as you can see, 94% runtime. Memory is, I don't know how that got worse. Actually, I do know. It's because we used a hash map, so that's ON, space complexity. But as you can see, nobody cares about memory. We just care about the runtime, so it's much better here. And basically, this is how we used hash maps to solve this problem. If you look at the topics, actually, it does say hash map here. So whenever you're solving a problem, you might as well look at the topics. It can be a big hint sometimes. We don't really need these hints. So yeah, that's exactly what the hint gives us anyways. I mean, here, the next number, this basically remaining number, is target minus value. And then additional space with hash map. So this is what we did the first time, right? This is what we did from the first time, and that is using the double for loops, which is never a good thing. If you're in competitive programming and you're trying to do something with good runtime, usually it's not going to be good to use a double for loop unless it is a matrix. Then maybe you do need to use a double for loop to check every element in the matrix. But you should always look for optimizations for ON time complexity like this. Just a single pass will work. Okay, thank you for listening. I'll see you in the next video.